Hello and welcome back. As we continue our series of videos on forecasting in Excel, I want to build upon what we learned with moving averages and with linear regression and the forecast linear function. So before we talk about a different kind of forecast function, which is FORECAST.ETS, I thought it would be a good idea to do some quick review. Now, this review will be kind of brief. So if you really need to deep dive and you haven't watched moving averages and linear regression, those are two different videos. So linear regression is one video. Moving averages is a second video. Go back and check those out. This should come third after those two, specifically or preferably after moving averages. So linear regression first, moving averages second, and then this should be third. But here's a quick review. So in our linear regression video, we used some historical data to try to predict the value of a home based on square footage. And we did that both manually and we also used the function FORECAST.LINEAR. So I want to remind you about that FORECAST.LINEAR function. So first, here's the quick manual. So you know the formula for a linear equation is y equals mx plus b, where m is the slope and b is the intercept. You fill in the value of x, that's going to make your prediction. So for example, if we have intercept and slope, intercept is 48,052, slope of the line is 99.639, and we want to predict the value of a house that's 3,100 square feet. We simply do that math, right? There's the math, y equals mx plus b. So C13 times 3,100 plus 12, okay? Ooh, we don't want to put that in there. And that tells us 356,936. Okay, that's the easy part. So on top of doing this the long way, I showed you that there's a function that can basically do the math for you, right? So whenever you have a formula that just was repetitive, most likely there's a function that can do it for you. And that function in this case is FORECAST.LINEAR. This one. Okay, so in the forecast linear function, you give it the value you're trying to predict. That's the value of x, 3,100. You give it your known historical y values. So that's going to be the historical price of the homes. The known historical x values, that's going to be the value that you're using to make the prediction. That's your square footage. And guess what? 356,936, 356,936. Right? So you can do it manually, which is what we did originally. That's always a good way to learn. And then the function does the same thing, right? So it's as simple as when you use the average function, you know how to manually calculate average. But now that you've learned how to calculate average, might as well let Excel do it for you. Okay. Well, I want to build upon this when we're working with nonlinear data. That's where moving averages came in, right? So the first example in our forecasting was dealing with linear data, right? So the data tends to be somewhat in a line linearly. Then we moved from that into data that was seasonal data. That was our airport passenger data. And you can see that here. Let me show you. So when we plot this and look at it, this is no longer linear, right? This is seasonal data. Now, in the previous video, I showed you one methodology to deal with or to create a forecast model to deal with seasonal data, and that would be moving averages. What I want to do is build upon that with some other functions built in Excel that are super handy for making predictions, all right? So the first function I want to show you to add on to what we've learned already, and this is pretty quick and easy, is the FORECAST.ETS function, FORECAST.ETS. So ETS stands for exponential triple smoothing. It's a big old computer guy sounding thing, but basically what that means is it's a better algorithm for dealing with data that's not necessarily linear. So what can that do for you? So what you'll find is if you've got data that's seasonal, the forecast linear function isn't going to work, right? Because the forecast linear function is going to try to do what linear regression does. So it's going to try to apply a linear trend line and then extrapolate that out in order to make the answer. Okay. So we know that's not necessarily the best option. Okay, oof, we don't want to click all that. Now in the previous video, we also learned how to use moving averages, right? So we could set a 2 or 3 or 4 period moving average, depending on what you want the window to be. And if we do that moving average, see the moving average is a lot better than that linear trend line. So there's the linear trend line, there's the moving average. That was better, okay? Now we don't want that trend line for this. So we'll take that away. Whoop, too much, went one too far. Let's make that again. So what I want to show you how to do is, instead of doing a manual calculation or instead of creating a plot, I want to show you how to use a function to create a forecast for one time step into the future. And I also want to show you another cool feature in Excel called Forecast Sheet, which is also pretty trendy. So let's start with FORECAST.ETS. So what is that going to do for you? So the FORECAST.ETS function is super handy, and I'll just start right down here. So what FORECAST.ETS does, and you notice there's a bunch of these. I'm going to show you FORECAST.ETS. I'm also going to show you forecast seasonality. So let me move this up a little bit. Okay. So let's start with FORECAST.ETS. So notice with FORECAST.ETS, the first thing you have is you can give it a target date. So remember, with moving averages, we could predict one time step into the future. In this particular case, we're going to try to predict one time step into the future. So we'll say our target date will be October 2013. So now from there, it's going to say, well, all right, what are my historical values? My historical values are going to be my airport passenger data. There we go. And then it's going to say, what's my timeline? My historical timeline is going to be this. Okay, so now within the FORECAST.ETS function, and let me pop it up this way so you can see it. There are two optional arguments that are super handy. One is seasonality and one is data completion. So the first thing with FORECAST.ETS is the seasonality option. So with this seasonality option, you can put in 0 or 1. Okay. So if you put in 1, Excel is going to default try to figure out what the seasonality of the data is, and it's going to adjust based on that. So it's going to know, oh, this is seasonal data. I'm going to go through and calculate as such. If you leave it at 0, it's going to assume that there is no seasonal data. See, and it tells you that down here, indicates seasonality as detected. The other thing that's super handy with this particular function is that it can actually deal with null values. It can deal with missing values, which is super duper handy. So in the event that there are missing values, you can go through, and if you set it to 0, it will account for the missing values. And if you set it to 1, it's going to average the neighbors around it in order to do it. So with 0, it will calculate the missing values at 0, and with 1, it will average the values around it, which is super handy, right? So, and I kind of fumbled over that, so let me say it one more time. So if I put in a 0 here, if there's a null value, it's going to just consider that a 0 value, like literally 0, so like no one flew. And if we do a 1, then it's going to default average those things together, which is super handy, right? So it's going to then say, well, it's going to replace those with whatever is the nearest neighbors instead of replacing them with the value of 0. So super handy there, okay? So if I do this, it's going to make my prediction based on that, okay? So better used for seasonal data. Really, really simple, FORECAST.ETS. Now, one thing that's really interesting about FORECAST.ETS that I want to point out is this one right here, that optional argument about seasonality, where it says, hey, if you put a 1 here, it'll try to predict what the seasonality of the data is. Let's talk about that for a second. So when you look at this data, you can clearly see that it's seasonal because you have a repetitive pattern that's happening, right? And on top of the seasonality, you can tell that there's a trend because it's seasonal, it's repeating, but also it's trending upward simultaneously. So it's not like a straight line across. So remember, you can have seasonality with no trend. You can have seasonality with trend. So it can trend up, it can trend down, okay? And all of those things happen in real world. So what's really cool about this in this particular example is you can look at this and you can tell very much so that the seasonality is happening at the month or at the year level. Like, so there's seasonality throughout the year. You're seeing that happen? Seasonality throughout the year, right? So there's January to January, January to January. So you see how that pattern is repeating year over year. So there's 1 year, there's 2 years, there's 3 years, there's 4 years, and then we've got most of that final year. That pattern is repeating. So you can see it visually that it is it's 12-month seasonality. But if it's not as easy for you to see, or the numbers are not as simple as this, you can actually use another function. That function is called forecast seasonality. So check this one out. See that? Forecast seasonality. So with forecast seasonality, it does a lot of the same stuff that FORECAST.ETS did. But what it's going to do is it's going to return the seasonality for you. So for example, if I give it the values, and then I give it my timeline, like so. Now, again, it's got some cool features in here. So let me pop it up this way so you can see it. So one, it can handle missing values the same way that FORECAST.ETS handles missing values. So depending on if you put a 0 or a 1 here, it will calculate either as a 0 or the average of the missing neighbors. And then you can tell it when it does extrapolate how you want it to actually do that. So do you want it to average, take a count, take a min or a max? And in this case, for example, we don't have any missing data. So I'm simply going to type this out and let's see what it tells us. So we'll go forecast seasonality. Let's give it our values. Let's give it our timeline. And it's going to tell us 12. Now this supports it, right? So it's saying that, hey, the seasonality is 12-month seasonality. So the pattern is repeating every 12 months. There's January, there's the pattern, there's the pattern. So these are super handy features that will help you do some additional analysis in Excel. The forecast seasonality function is really good when you're building reports or dashboards where you want to track data or you want to actually output something saying, hey, look, this is the seasonality of the data. The FORECAST.ETS function is better at making the prediction. So this will tell you something descriptively. FORECAST.ETS is going to make a prediction into the future. FORECAST.LINEAR is also going to make a prediction into the future. Super handy. So there's one more quick thing I want to give you before this video gets too long. I want to show you the, let's get there. Let's see here. Forecast sheet option. Now, apologies to my Mac users. If you are on a Mac, the forecast sheet feature is not included. But what the forecast sheet feature is it's going to do for you a lot what FORECAST.ETS does, except it's going to give you a visual and a numerical output. So let me show you. So if I select all of this data and I go up to the forecast function, which is part of my data tab. So data tab, forecast function, and I click forecast sheet. Check out what it's going to do. So it's going to plot it for you. Okay. Now, on top of plotting it for you, I can then say, hey, I want you to extrapolate this out and tell me what, any step into the future is going to be, right? So at this particular case, it's going 2 whole years out because our data stops in 2013. It's forecasting all the way out to 2015, and then it's giving you your residuals. Now, what is that going to do? Let's just create it, and then you can see it. So here's our forecast sheet. Okay. So our sheet is here and our plot was automatically created here. See it? So there's our original data. There's the extrapolated data, and see how it's giving you the upper and lower bounds. Like, so it's saying, hey, like this is our data. Here's our confidence levels moving forward. Okay. Now for that first month, we feel really confident, but notice as we move forward, we're seeing an error. And it's telling you like, hey, this is the upper error. This is the lower error, right? So there's our prediction, upper, lower error. And it's also plotting it for you here. So this is the actual tool, honestly, that I like the best if I really want to just quickly get a prediction. Now, I would dive deeper into this and I would look and use other methods besides just the forecast sheet. But it's really, really handy if I want to do something quick and dirty and just say, look, like if we extrapolate this out, this is most likely where we're going to end up plus or minus. So see that orange line is the prediction. The thin orange line is the upper bound of the prediction, and the thin line here is the lower bound of the prediction. So super handy. And what's also nice over versus moving averages is it will go out farther than one time step into the future. Because remember, with moving averages, you can only do t plus 1. So if you're predicting months, you can only predict 1 month into the future. If you want to try to extrapolate that out farther, FORECAST.ETS can handle that, right? And this forecast sheet, which is using FORECAST.ETS, can handle that for you as well. Okay. So with that, I don't want to go over 15 minutes. I will let this go. Hopefully this is helpful for you. See how it's giving you the FORECAST.ETS function right up here. It's doing that for you. Okay. So hopefully that is helpful for you, and I will talk to you again in the future.